Alright, we are in AP Calc. We're looking at Chapter 5. It's kind of, again, a summary of Units 1 through 5. It does have elements of everything that we've talked about so far with frequency tables, some vocabulary, things like that. But this one is mainly going to focus on our summarizing distributions. And throughout the summarizing distributions that we will be talking about, we will be discussing a measure of center, all right, a measure of spread. We've kind of hit on the center of data and spread of data before, but we're going to hit on it a little more here. Measure of position of items. We're going through the simple background of the empirical rule as well. We're going to hit on histograms a little bit more than what we were talking about before. We're going to introduce to you some more ideas of box plots, which you basically already know. But hit on it in this course mainly. We're going to be comparing different distributions to one another. We're going to be changing units as well. But the first thing we're going to talk about is, let's worry about finding the center of data. All right, and basically the idea is, where's the middle, right? The center, where's the middle of it? What is the most of the data doing? Like, what is a majority of your data going to be doing, is what I'm basically saying. And we'll talk about a change or variation in that data, is what we're going to kind of elaborate on. And again, most of the stuff that we're going to be going over in this chapter, you've seen it before. We're going to talk about outliers, right? And if anything in the data changes over the time with those outliers, and we went kind of over those in the prior sections as well. So let's describe our data, shall we? There are 5 different characteristics of the data. All right. We have the center. You have the variation of the data. We have the distribution of the data. We have outliers and the changes over time. Okay, so we're going to hit on all of these basically in this set of videos. So we're going to start by looking at the center. Okay, the center, which really basically means what's happening in the middle of our data. It's what you would expect center to be. What value is most of our data surrounding? The center is basically the middle of the data, and we have 3 ways to describe the center of data. Okay, 3 ways to do it, and these are all things that you know. One of them is the average. All right, average is the one that most kids go to immediately, right? The average, that's the middle. If I asked you to find the average age of this classroom, you would add up probably all the kids from this class and divide by the total number of them. Something that you've done probably since elementary school, right? But the mean is what we call the arithmetic average, all right? The arithmetic average. And you add up all the things that are in that set and divide by the number of things there are, right? There are 30 kids in a class. You add up all their ages. You divide by the number of kids, which is 30. So here's a symbol or an equation for it. Mean equals. Now, again, this sign that you see is a summation. It means sum. Sum of all those different values that you're looking for divided by the number of values that were in your data set. So remember, sum. X is the variable. Let's rewrite the bottom as n instead of number of times. That's all. N basically means the number of them is all. So this is basically, if you see it, what it means is that means the mean. That's what it means. All right, and in a population, we use capital N. All right, we're going to get through this idea of distinguishing between if it's a population I'm looking at or is it a sample that I'm looking at. All right, so a capital N is for a population. So in a sample of the population, we use the lowercase n in a sample. Okay, if we're talking about a mean of a sample as well, you're oftentimes going to see X bar. All right, so you're going to have to get this terminology down. It will distinguish between whether something is a population to the reader of the problem or if it's a sample that you're looking at. If we're talking about a mean of a population, we use mu. All right, that's what it's pronounced as, mu. All right, it's the Greek symbol. All right, some people combine the two, and when they're talking about a sample, they'll always say mu for a mean, but then they'll put a little sub X with a line there, depending on which book you're looking at. That is called X bar, by the way. So we now have 2 different formulas that are very similar. All right, this one is talking about the sample This one is talking about the population, right? Population, large N. And again, sometimes you might see this as a mu with that little beneath it, okay? That also means sample. But basically, whenever you see this, that's talking about a sample mean, and that lowercase is a sample number of items. The idea of finding the mean is the same in both. All right, we're doing the same thing, nothing changes. All right, let me give you some sample data. Right, let's say you found in your car $5.40, $1.10, then 42 cents, 73 cents, 48 cents, and $1.10. And again, before I continue, remember with all of my videos, pause them, write this stuff down so that you can keep pace if I'm moving fast. If I wait for you to fill everything in, then the videos will be hours long. Okay, so pause the video, come back, right? So anyway, you have all those down, all right? This isn't the overall change that you found in your car every day, right? This is one day, another day, another day, another. So you can add these all up, and that's how much change you found in those amount of time. But if I wanted to see the average or the mean, all right, that's what we would get. But the point that we're getting at here, so that you understand, is this isn't every change that you've ever found in your entire life of having that car. This is just 5 random days, or 6. 1, 2, 3, 4, 5, 6. This is 6 random days. This isn't the change that you found in your car every day ever, which means that's why we're saying this is a sample of a couple of times that you found change in your car. This is just a sampling. If this is just a sampling, that's why I'm going to use the sample one. So that is my sample formula, which means I take all of them, I add them all up, I divide by 6, and I end up getting that. So I should roughly get about $1.54 every day. All right, and I check in my car. All right, that's basically what it means. That's the average. When I randomly look, I should be able to find about that in my car. Now, is $1.54 in our data set, right? The answer is no. I don't see that number anywhere in my data set, right? But it's a number most of our data is close to. It is our expected value. That's key, right? This is way too much, right? These are way too little, but these are, even this is way little, but those are kind of around there, so they average it out, basically, but it's what you expect to find each time. All right, the next measure of center is your median, all right? And you've probably heard of this one before as well, by saying the median salary or the median home value. And why are they using median average and not the mean or the arithmetic average? Why do some people use median instead of mean, right? No one's ever really taken the time probably to explain the reasons why all these different measures of center are made for you. So that's what I'm hoping to find out, so we can introduce that idea to you. So I want you to think about this logically. If all the information is there, would we not add up all the prices of homes in the area and divide by the total, right? Why wouldn't we just do that? All right, now hold that thought so we can come back to it. The median is the middle value of our data, the exact middle. If you arrange the data from low to high, the middle is the median. All right, and if I gave you a list of numbers, what's implied by saying the middle? The middle of a list of values. So for example, if I gave you all of these, right? If I gave you all of these, just find the middle. I can't just say, well, the middle is right there. It's not the middle. I have to arrange them in low to high first. They must be in order. But why? Right? It's not in order. The middle of our data is currently 7 because it's not in order, but technically 7 would not. It would be an outlier in this problem. So 7's outside the normal data set. So middle implies that we need order. And finding the median implies that we must arrange our data in order. Median is the middle value of arranged data in order. All right. We could have an odd number of data values or an even number of data values. And again, this, you guys have seen this so many times. It's why I can kind of burn through this a little faster than some of the other concepts. You know how to find a median by this point in time. I hope so, before you get into this course. But the point is, I took the data, I arranged it, and this is the exact middle, 3. There is your median of the data, right? That's our median. Odd numbers of values, literally the middle, is the median. But if we had an even number of values like this, 1, 2, 3, 4, 5, 6, what's the middle? All right, does anyone remember how to find that? Well, we basically take the arithmetic average, or the mean, of the two numbers in the middle, 4 and 5, and divide by 2, right? So it's a sample. It's not every number in the world, so it's a sample. Divide by 2, we get 4.5. So let's try an example, right? Find the median of this. So again, pause the video, write it down, see if you can find the median, and I'll go over it. But we arrange them to get this. I try to find the middle, so that's 4, and it's exactly, let's see, 1, 2, 3, 1, 2, 3, there we go. So our median is 6. Let's say I add a number to the problem, and I make it this way now. It's 412. Now pay attention to this example. This will help you explain the home example I gave you earlier, the idea with the homes. If we have this arranged, right? Now if I go to find the middle, there's 4, there's 4. I would take the two middle numbers and average them together. 6 and 8 divided by 2 is 7. So by adding or subtracting a number from the data, we can change the median of the data by just putting a number out there. Not always, right? So again, taking a look at this, if I added another 6 to the number, right, we would get 6 and 6 is 2, right? Because that's the middle. 4 and 4, there is the middle. 6 and 6 divided by 2, it's 6. So let's find the median of the change in the colors from earlier, or the change here. If I arrange the change in order from low to high, there we go, 1, 2, 3, 1, 2, 3. Oop, I got to find it right in the middle. And when I find it right in the middle and add it up and divide by 2, I get about 92 cents, right? So I asked earlier for you to think why we would use the median instead of mean, right? Why would we use median instead of median? Notice what happened to the car change example. When we first did the problem, we said the mean was $1.54. And now we just found out that the median is roughly, we'll go with 92 cents. These are both different measures of center, but the idea is which one's more accurate. That $5.40 change out there changes the middle from a mean, but it really doesn't for the median. The point is, the really, really high value alters, and it drastically altered the middle, right? It brought up my center a lot. I should be getting about 154. But realistically, I barely got even around 154, right? I barely got around that. But that one single value bumped it up, right? That one single value bumped it up. So let's say we found a pot of gold. So actually, you know what? I don't want to race through here. So just keep that in the back of your mind, and we're going to continue on with this idea about how possibly outliers affect the median of items when we come back.